The battery, starter, and alternator on a modern vehicle are all designed to work together, managed by an electrical power management system. These components together can be thought of as the electrical heart of a modern vehicle, and they require advanced equipment such as a Carlisle electrical system tester to ensure their proper operation and to tie them all together. It's easy to think of an alternator as a mundane component that reacts to basic electrical principles to produce an output which can recharge a battery. However, modern batteries demand a very specific charging profile to prevent damage and extend the life and performance of the battery. In addition, an alternator requires power from the engine to rotate. The higher the output, the more power required. By controlling the output of an alternator, the power required to rotate it is reduced and fuel economy is increased. This is accomplished by an adaptive charging system. An adaptive charging system monitors battery voltage and estimates battery condition in a similar manner as a modern battery conductance tester. Using this information and system logic, it controls the output of the alternator and may enter any number of different charging system modes, including a charge mode, battery recovery mode, fuel economy mode, headlamp mode, start mode, and even a tow haul mode on some vehicles. Therefore, battery condition has an immediate effect on charging system output. As a battery ages and its working condition changes over time, the charging system parameters will change to maintain the optimal condition of the battery. For this reason, most vehicles require a reset when the battery is replaced, so the power management system knows the correct baseline of battery performance off which to base its logic. The starter is the third member of the electrical trio that works in harmony for maximum vehicle efficiency. A worn starter can cause excessive current draw, causing difficult starting, but also increasing the load on the charging system for battery recovery. Starter condition becomes even more important on start-stop equipped vehicles. The health of these three interrelated components is further linked by the power management system with operational safeguards. On a start-stop system, if the system determines starter operation has exceeded a preset number of times within a predetermined amount of time, the start-stop function will be disabled. If it determines that battery state of health or state of charge is too low, a start-stop system will also be disabled. One item to never forget is what connects the battery, alternator, and starter. Often these wires and cables can no longer deliver the current required due to physical damage or corrosion to the connectors and inside the wires. When you test the system with a voltmeter, you might see full battery voltage at the starter, battery, or on the alternator. But when the key is turned, you'll see a significant drop in battery voltage and hear a slow crank from the starter. In some cases, the system voltage at the alternator might be lower than specified. What's going on? It's called a voltage drop. There might be a bad connection or the wires inside the starter cable are damaged. The cable might pass static voltage and resistance test, but when the circuit is loaded, it can cause significant voltage drops that can cause a multitude of problems that might mimic a bad starter, alternator, or battery. Build-in electrical cables by NAPA Eklund covers just about any vehicle you're working on. The line includes fully assembled battery cables for specific applications, as well as generic cables of various lengths and connectors. The cables are made of a tough, durable synthetic rubber that is resistant to corrosive elements like oil and coolant. In the past, when a vehicle came in the shops for service, testing the battery was considered a routine service, and certain times of year, such as going into the winter, often triggered greater awareness of battery condition. Today, however, it's recommended for technicians to test not only the battery, but the operation of the rotating electrical components as well. When handheld battery testers were first developed, they were limited to this single function. With the evolution of vehicle technology that has tied batteries, starters, and alternators together as integrated functioning systems, the single function tester has been eclipsed by advanced comprehensive equipment, such as the line of NAPA electrical system testers, enabling technicians to perform complete, accurate testing on these integrated systems. This equipment is designed to test the battery, starter draw, and charging system output quickly and easily. Many communicate with the vehicle via the OBD2 port to obtain operational information from the vehicle computer, and once battery information is entered into the tester, technicians are guided through the testing process for each component. Most are designed to either print test results or send them electronically so they can be shared with the customer.